Hello everyone. Let's start the Z4 framework learning today. And what is Z4? Z4 is a multiplayer and online real-time game server framework. It can help developers to build decentralized games. It includes smart contract on-chain and off-chain interactions, RPC and P2P network, game logic interface, and game room management. Developers only need to focus on the game logic and will not care about the blockchain, the KP, and the network. Developers can freely to customize their own Z4 node for their games, or they can use general gZKm Z4 game nodes. Okay, we will explain how to customize Z4 nodes. Okay, first let's install Z4. For example, first you need already install the Rust and the Cargo. We use Cargo to install Z4 commands. Okay. Because we already installed the Z4, so it's okay. So we use Z4 to new a game. Use this. For example, game 1. Okay, it will clone Z4 template from the GitHub and use the defined. We use customer ZK and Solidity. You can see what's the dictionary. It includes some contracts in Solidity and also already have a handler and a main in Rust. Okay, we can have a view about the Rust code. So here is the main file called handler. In the handler, we can see it has players, operation, and the game handler. The handler is a core interface in the Z4 engine. It defines all the methods when your game logic interacting with Z4 engine. For example, we can see the accept method. When a game created in the chain, and the Z4 engine will find it and it will pass the game to accept method. You can see the parents. It includes the player's ISM address, a local game, local generated account, public key, and the public key. See, this is the local account PID. PID is equal address here. And you can create your game logic to return a value to the chain. And when the Z4 node accepted the room, that means the room will running on this Z4 node. It will call this create method. The method include some paraments. It includes the peers. Peers is the players, this room players, and paraments. Paraments is which when you submit to the chain when you accept this return value is the paraments, and the room ID and the seed. Why here has the seed? Because some game need random, so we use the seed here. The seed is generated from the chain and the local Z4 engine. It can be approved by the key. Okay, it will return the handler and some tasks. Yeah, we build an account and empty operations here. So next one is online and offline. That means when a player connected to the for node, it will call this online method. You can do some kind of logic in this method. And when a player disconnected, you can do something game logic. And the last one is the handler. Handler is the main method here. It will handle all the messages from the player. So you can see the parents is player, method, and the parent. Because in the for node we use gZKm format, so it has method and parents here, and the result also is method and parents. We have also already built in some helpful methods for it. Okay, in game logic you can check the method is what and do some logic here. So when the logic is finished, you can return the handle result. For example, here is a broadcast method and the parents to all the players in this room, and you can also just send some player. Yeah, and after handle this game logic, you can push the operation to the operations. We store all operations for better doing ZKP. When the game logic find the game is over, then they can do the ZKP. Here is the game rank. You can see here is which account has higher rank. So it is the order. Because in the Z4 contract, we only accept the rank, the address list here, and then is the proof. And you can customize this logic in the contracts, in that smart contracts. If you don't change it, it will use the address list and the proof bytes. So you can see here is the to do. You can doing your customer ZKP or doing the ZK by ZKVM. So here is the submit the over status to the chain. Just it. Yeah. Okay, that's a main handle. So when you customize the handle, you can start the for node. You can see it will configure from environment. Yeah, we use the environment here, and then start the engine. Use the engine to start it. So how about the environments? We can see an environment template. You need to define the network and the game's contract address here. Yeah, for example, I used local is a node, and then the address is here, and you need also set the for node account. It use the secret key here, and you can customer start block to sync from the chain. If not set, it will from the latest. You can also set the RPC endpoints. Yeah, and the URL here is about your public URL, because when your this Z4 node register in the chain, you need to set a public HTTP or WebSocket URL, because other players can connect to this node. And here is the port. Okay, here is the port. And this way is about the staking. If set true, it will out staking. Here is about the room market, because where our game and room market, you can define the two contracts here. In the Z4 node, they will use this room market address, and others is Rust log. Okay, that's environment. So let's have a view about the contracts. Okay, that has room market. Room market sequencer. This sequencer is the Z4 node. You can find all the sequencers or all the Z4 node in the network. The Z4 node need a staking, and then they can accept a task. So here is create room. When the player create a game, that means they will create a room here. So you can see here has a sort. Yeah, that's about the seed in the Z4 engine. Okay, this is join room. When the player saw some rooms in the pending, they can join. And here is accept and over the room. Okay, so when you customize the contract or don't do any others about it, you can you can take this contract to remix or just head ahead to create a smart contract project to deploy. Yeah, here is simp. You can do some change or not. Yeah, it just okay. Okay. Here is about how to use Z4 node with customer ZK. Next, we can have a view about how to use RISC-0 ZKVM. Okay, let's create new game. As above, we use Z4. Use Z4 here. Z4 new game. We call it game 2, and ZK is RISC-0. Oh, it failed. Okay. It will also clone the code from the GitHub about the RISC-0 VM. Okay, I can have a view. Here also has a default template and the contracts also here, and the RISC-0 ZKVM starter, for example, first, and the method is the call logic. Let's have a view. Method guest is the logic. Okay. You can see here it also defines the operation here, and you can do, because we store all the operations, so you can just pass it here, read from the outside, and do the game logic here, and after the logic it will output the result. It will commit this result and commit the cycle. Okay, so how to run this ZKVM? It's in the host. Yeah, let's have a view. It's a very simple example about how to run this ZKVM. It will call this proof, passing the operations, and output is the rank. Rank list. And we pass these operations to the ZKVM, and here to do the proving, we use Groove 16. We use Groove 16 to generate a simple proof. It's better for the verifying the chain. Okay. So when you set the Buildathon API key, it will use the Buildathon client. If not, it will use the local computer. It only support x84. Yeah. Okay. More information about this documents, you can find it here. What is Z4 and how to customer Z4 node. So here we'll extend all the methods, and you can also find this information in the workshop here. It will have the one-by-one steps. Yeah, that's about how to build a decentralized game with Z4 engine.